Okay, the first thing to realise with this question is to work out frequency density there is a triangle. Isn't there always a triangle for everything? And the triangle is frequency at the top, frequency density, and class width at the bottom. Now this is a bit of a weird triangle because actually it's not quite right, because the frequency density is proportional to the frequency divided by class width. So sometimes the frequency density will be twice as big as you'd expect. So you do frequency divided by class width and it will be half as much. Or you can divide it by 3 or divide it by 4 or 5 or whatever number you want. So that's not quite accurate, but for our purposes, as long as we remember frequency density might be a different number, but it will be proportional. So if one of them you have to times by 2, you have to times them all by 2. So I'm going to do the class width column first. And the class width is just the width of the group. So 0 to 10, the class width is just 10. 10 for the next one. Then 20 to 25 is going to be 5. And I'm writing small here. And 25 to 35 is 10. And then the last one is 15. So that's the class width sorted. And the frequency density then is just the frequency divided by class width. So we're just going round and just dividing them all. Okay, so 7 divided by 10 is just 0.7, and then 10 divided by 10 is just 1. 6 divided by 5 is going to be, what, 1.2? If I can draw it. See, I'm writing too small here, let's try it again. So 1.2. 9 divided by 10 is going to be 0.9. And 6 divided by 15, oh, that's going to be quite a tricky one. So let's do the bus stop method for this. Can I do the bus stop method? Or so I could do it as a fraction, 6 divided by 15, and I notice that I can divide top and bottom by 3, so that's 2 over 5, so it's just 2/5, which is going to be 0.4. There we go. There's always a way. Right. So we've got our frequency densities. Now we've got to figure out what scale to do on the left-hand side for our frequency densities. Well, our highest number is this 1.2 here. So we need it to at least go up to 1.2. So if I go up in 0.2s, 0.2, 0.4, 0.6, 0.8, 1, 1.2, that would be perfect. So I'm going to go up in 0.2s. 0.4, 0.6, 0.8, 0.9, almost. 1.0, I'm just going to put 1.0 because it's a bit easier and it looks nicer, and 0.0. Okay, so we're going to start drawing the histogram. Now to do the histogram we just need to make sure that we have the correct ranges. So first one's 0 to 10, and it's similar to like a bar chart. So we're going to go up to 0.7 for the first one. So it's going to go up here. It's going to go across to 10, and then down. It's not perfect, but we can cope. Next one is 10 to 20. So we're going to go up to 1. Okay. Next one is 20 to 25, so we've got to be careful here. So this says it's 1.2, so we're going to go up to 1.2, across, and we've got to be careful, go to the right place, because it's only 20 to 25. And what's the next one? 25 to 35. So 25 to 35, and it's going to be 0.9. And the last one, 35 to 50, is 0.4. There we go, and that's our histogram. You probably will need to draw it a little bit more precisely than I've managed on this. Okay, so let's have a look at the next question. The next question says that work out an estimate for the number of trees greater than 40. So if I draw a line up at 40, and we're looking for these guys. Now, the total frequency of that bar is 6. And I've drawn a line that cut off, if I shade it in, I've cut off a third of it. So it's gone a third of the way. So we're looking for 2/3 of that 6. Well, 2/3 of 6 is just going to be 4. So the answer to question B is 4, because there's 6 in total and we're looking for 2/3 of it.